Hi, everybody. I'm Ed Liu with B612 Holding Company, and I'd like to talk to you about Space Map. What we're trying to do is make space navigation simple, and I'd like to tell you why that's so important. Next slide, please. So the first thing to know is that 99% of the solar system is unmapped. The vast majority of objects in our solar system, of which there are millions, are currently untracked. That includes asteroids and all of the small planets, nearly all of them. One of the things that I think many people miss when they think about the opening of frontiers is they think it's about the explorers or the discovery of resources, or sometimes people feel like they're a little bit smart and they go, oh no, it's about it's about selling shovels. One of the things I think people realize is that the real winners are often the folks who map things. And if you look at history as a guide, you'll see that everything from the great age of exploration, when the major powers sent explorers around to map things, they won out big, to the very first international company, the Dutch East India Company, which based its power for 200 years on the fact that they had superior maps to anybody, to Craig Venter in the 1990s, who first mapped, together with the NIH, the human genome. Mapping has been actually the thing that has brought the greatest strategic and economic advantages. Next slide. So why mapping of space? Well, first off, it's the key to where everything is. So I think I'm going to argue that the economic development of space depends upon actually mapping where objects are. And we'll talk about why that's kind of difficult. Number two, it turns out that asteroids do hit the Earth, in fact, on occasion. If you can go back to the last slide. And number three, understanding the origin and evolution of the Earth. Now you can go forward. So what our goal to do is to build the first comprehensive map of the solar system. Now it's difficult because every single object is moving. So unlike a static map of some territory on Earth, what you actually have to do is understand where objects are, where they're going, and where they're going to be in the future. That's the important part about it. So right now, it's a difficult problem. It can be done. It can be done by experts. It can be done by people with PhDs and in large groups. It doesn't need to be that difficult. We can make this as easy to use as Google Maps. And we want to become the de facto standard for space-based navigation, which, if you believe the space economy is going to get larger, this is going to be crucial. Next slide. So we've got a lot of traction with partners. We can talk about this later if anybody has any questions. I'll just move on from here. Our group, I'm a former NASA astronaut, 30 years experience in the industry, and was one of the early members of building Google Maps. I think in order to do a project like this, in order to build something like this, you need to have three areas of expertise. And without all three, you can't do it. Number one, you need people who know astrodynamics. That's the study of motion of objects in space under influence of gravity and other forces. Number two, you need to understand large-scale computing, cloud computing, and software development experience. And number three, you need to understand the industry itself, the space industry. We have people who have decades of experience in all three. Next slide, please. So what's our core technology? Well, essentially, it is a cloud-based platform, kind of like Google Maps, that does calculations of where things are and where they're going in space. Millions of objects, so it has to be done at scale. Next slide. So what is the need for this? What is the use of this, and where are we at today? Currently, it literally takes a PhD, as I said, to understand where a particular object is. If you want to go to an object, if you want to fly to a point on the moon, if you want to fly to a point on Mars, you hire yourself a team of PhD astrodynamicists, and you let them use software that they buy at $250,000 a seat license. They'll work it out over a couple of years. This is very similar to the way things were in the 1990s with geographic information systems. If you wanted to plot a course between, like how would I drive between where I am and some point, in Canada, well, you could hire people in 1990 to look at the satellite maps and figure all that out. Or today, My 12-year-old daughter can go do that on Google Maps. There is no reason why this can't be, similar thing can't be done for space trajectories. We can change all of this if we're smart about how we do the data interfaces.
Hey, Ed, 30-second warning.
Okay, next slide. So the market, it's all these people who are building, flying, doing space missions, essentially. Long-term market is large, and that's what I'd really like you to think about, the fact that the importance of the map, just like in every other frontier, scales with the size of the economy of the new frontier. And if you believe that over the following decades, the space economy is going to grow, then this is going to be underpinning all of it. Everything depends upon its location. Next slide. So once again, just to summarize, whoever controls the space map, as in all other frontiers, is going to have these tremendous economic and strategic advantages, and that's what we're aiming to do. Thank you.
Thank you, Ed. That was excellent at B612. Let's open up to the panelists. Any questions?
So,